Operation IceBridge is a NASA program to survey the Antarctic and Arctic ice sheets. It's multiple planes and multiple instruments, and they go every summer season in each area to make measurements of the ice sheets. Before the partnership with Indiana University and Center for Remote Sensing of Ice Sheets, they were basically storing data as it came off their radar systems on laptops or USB drives and carrying it back to the US in suitcases or duffel bags.
So before then, they would look at their laptop and connect their laptop. Now they can really take a good look at the data using the cluster that we put on the plane.
Basically, we've been required to create a data storage system in a very, very small space and very, very small power envelope that can provide significant storage and computational capacity. The work that we're doing in Operation IceBridge is a little bit different than what we normally do. Usually what we do is here in the data center, and we provide data storage and processing and support for people who want to run their research on our systems.
Basically what we've done is we've taken what we do in the data center with supercomputers and we've shrunk it right down and taken it into the field.
It's not a full-fledged supercomputing system in a plane, but it's about as close as you're going to get. It's a scheduler, it's got scientific software, it has replication and automatic checksumming of the data as it comes across the radar.
So every year we've been involved, we sit next to them, we watch how they process, and we see how we can adjust the hardware or adjust the scheduler or the software they run so that it runs more efficiently.
The way the IceBridge missions work, it's a very long plane ride over very boring conditions. And the general mission scientist from NASA tends to walk around and ask the teams, what are you getting right now in terms of science? And what we've been able to do is take that from pretty preliminary results to basically full processing of the data as it's coming off the radar systems. So about 10-second delay, and they've already got visual representation of what the plane is flying over from the radar system. So that's a pretty big benefit in terms of what they can show right as they're collecting.
On a sea ice flight where they're just looking at sea ice and no land, they may collect 3 to 4 terabytes, and that could go as high as 5 to 6 if they're looking at land.
They write a lot of these files, so generally a field mission will return with about 80 terabytes of data. With this partnership, we're out in the field, we're learning from the scientists as they learn from the systems that they're observing, and we're able to meet them a lot closer to the work and get really involved with the research process.
Our main focus while we're out there is for the researcher to be able to do research and not worry about IT. Let us handle the IT, so we'll handle the cluster management, we'll handle the duplications. We'll take that all away so that the researcher could just focus on the science.
We're usually pretty far removed from the laboratory or the clinical trial. But in this situation, our field engineers are right next to the scientists as they're collecting the data. And it's really exciting to see the kinds of connections that can be made and the understanding that we get from working directly hand in hand with our scientists.